Okay, so Unit 3 is lesson 4.3, so we're doing the first derivative test. First derivative test is what we're going to use to help us figure out the change of direction of the graphs, which makes sense because we've talked about that. We're doing the derivatives, which helps us tell you whether the graph is falling or rising, increasing or decreasing. So that's what, and that we've already kind of talked about that the last two lessons, so it's kind of the same stuff, but we just get a little bit further because it gets a little more difficult because now we're taking harder derivatives. Okay, so just to review here, so the local max and min at C, so C would be the height, the y value at that point. Okay, the local max or min comes from Fermat theorem. That's from last time. Fermat theorem was just saying take the derivative and look for increasing, decreasing changes. So look at this a little closer. So again, this is a spot where it's increasing. Here's a section where it's decreasing. If you're going increasing to decreasing, that creates a what? Local max. Okay, if you're decreasing to increasing, that creates a local min. Okay, and so that's the rules we're going to use today, and we kind of know that already from yesterday, or Friday, Thursday. Okay, so here's the first derivative test. You may want to write this piece down. So this is where, let C be a critical number. So critical numbers are what? That's what we did the warm-up for. The derivative being 0 or does not exist. Okay, so let C be a critical number of a continuous function f. If f prime changes from positive to negative at C, then f has a local max. That changes, if it changes from increasing to decreasing, it has a maximum. Okay, visually, hopefully you can picture that. If f prime of x changes from negative to positive, so decreasing to increasing, it has a local min. And if f prime of x does not change sign at C, then f has no max or min at C. So there is times where you'll test a D&E number and a 0 number, and they may both be plus plus. If that happens, there's no local min or max there. So essentially, the best way to tell you this is that just as it's a critical point does not mean it's a max or min. Does not mean it changes direction. You have to check it. Okay, so then moving forward here, here's the illustrations, maybe a little bit better if you like pictures better. So if your f prime to the left of C, so that's the left of a point, is positive, to the right of it, it's negative, that gives you positive, negative, local max. If it's negative to positive, negative, positive, gives you the cup, local min. This is an example of positive, positive. So positive and then positive, there is none. There's no local max or min there. And then same thing, but switched for negative, negative. Okay. All right, so example 1. So to do it now. So it says find the local max and min values of the given function x cubed minus 3x plus 1. Okay, so we are going to go ahead and do the derivative first. This is a simple derivative for us. So f prime of x is 3x squared minus 3. Okay. We don't have any D&E things to worry about, but we can solve by factoring. The first thing you should see is the what? Yeah, take the 3 out. That gives you x squared minus 1, which we now can do what to? Right, the difference of squares. Okay? So x 1, x minus 1. So if we're solving by factoring, again, back to the Math 20 concept, if we're solving by factoring, we now have critical numbers of 1 and negative 1, which make that equation equal to 0. So they are your critical numbers. Okay, now this is for what you guys are asking about. So what we're going to do now is when you have 1 and negative 1, think about them on a number line. Okay, sorry, I didn't mean that hash there. Just kind of think about a number line here, so you have 0 here. Okay, you're going to do a little table like this. And you're going to do x less than the smallest number. What's your smallest critical number? Then you're going to do between the smallest and the second biggest, which is just each other. Bigger than negative 1, but smaller than 1. And then you're going to do bigger than the biggest. So everybody see how I did that? I'm accounting for every section. Counting for this way, left of -1, between the two, and then right of positive 1. Does that make sense? And the second part that you're going to do is you're going to put the factors on top. So you're going to put x plus 1. You don't have to put the 3 because it's not a factor. So it's going to change the sign. Okay? And x minus 1. And then I put, just one sec, I put plus minus and then increase, decrease. Okay? Yeah, Emily? Last class? Yeah. Yep. Because we talked about max and mins. Because now we're putting it together because we didn't talk about the critical points last time on that day. So now we're putting the critical points with it. Okay, so this is all you do. So what is something smaller than -1? -2. -2 plus 1, is that a positive or negative number? -2 minus 1, is that negative or positive? Still negative because it's -3. What's a negative times a negative? Is that increasing or decreasing? That's how you fill out the chart and figure out what your graph is doing for that section. So on this cubic graph, everything less than -1 is an increasing part of the graph. So that graph is coming up. Okay? Between the two, so I'll pick 0. 0 is simple. I get a positive and a negative, which is negative, which is decreasing. Okay? And then I'll try 2. I get positive, positive, increasing. Okay? So back to the question, it wants to know your local max and min. So where is a maximum at? At the number 1. It's at 1. You're right, but not less than 1. So right here where it goes decreasing, we're doing maximum, right? So increasing to decreasing, that's a maximum spot. That happens at what number? -1. So the number -1, it's going to be a hill. Okay? So we have a max, or at -1. We'll figure out what the actual point is in a second. Just -1 for the x. Okay, we have a min, decreasing to increasing. That represents a minimum. That's at the number 1. How do you think we get the y? Because if you're decreasing and then you're increasing, that creates a cup. That's a minimum. If you look at the last thing you just wrote down on the definition, that's what it says. So if it's going down to up, that's a minimum. If it's going up to down, that's a maximum. Okay. How do you know it's at 1? Because that's the number that we just added in. So if I was less than -1, right, I was increasing. And then after I get past the -1, this is like past because it's greater than, it's now decreasing. And then I'm decreasing less than 1. And then after I'm greater than 1, I'm increasing. So that's the numbers that change direction. Because we know that 1 just from our critical points, something's happening there most likely. And so that's the change in terms of direction. Okay? So to figure out what those points are, in terms of what the max hill is or the min hill is, we plug it into the original. You take -1, you put it right here. So I give you -1 plus 3 plus 1. So that would give you 3. -1, 3 is a maximum point. Minimum point, 1 minus 3 is -2, plus 1 is a -1. 1, -1 is a minimum point. All right, next one we'll do, and then we'll also kind of graph it a little bit too. Maybe the graph will help you. Okay, so example 2, same idea. Find the local max and min values of the given function. Use information to sketch the graph. So we're going to sketch the graph on this one too. And that's what we're getting into right now. We're getting into graph sketching, curve sketching. So that's why we're looking at behaviors and when they change. Max and min helps us, gives us good information to sketch the graph. So this one's G prime would be what? 4x3. Good. Good. That's all it would be. The 1's gone. And then here, hopefully you see the GCF of 4x. Good. Okay. And then hopefully you see where it's going. It gives you another thing you can factor. So that gives you 4x times x minus 4, x plus 1. Okay. So my critical numbers are 4, -1, and 0. You have 3 critical points. Okay, so again, I'll make that chart again. Same thing I've been doing. So we'll make this here. Okay, so what's my first region of this graph? Less than -1. Okay, the next piece is between -1 and 0. The next piece is between 0 and 4. And the last piece is, okay. So there's our 4 sections. And that makes sense, it's 4 sections. Why? Yeah, because it's an x to the 4th, right. Because in the beginning it's x to the 4th, yes. Okay. And x squared has 1, 2 sections. X cubed has 1, 2, 3 sections. Okay. So now we put our factors here. So we put 4x, we put x minus 4, we put x plus 1, we put, did we get a plus or minus? And we put, is that increasing or decreasing? Okay. So, something less than -1. We'll start going around here. Rye, what's something smaller than -1? Okay, so Rye, does that make this one positive or negative? Okay, how about this one? Yeah, I'll have you do the whole line. Good. What's 3 negatives equal? That one's decreasing. Okay. Tyler, give me something between 0 and -1, so you're going to have to do a fraction. Sure, -1/2. So, -1/2, what does that make that one right there? Okay. Okay. -1/2 plus 1. Positive. And so how many negatives do you have? So that means positive. Okay. Good. Okay, Garvey, you want to try something between 0 and 4? 2. Okay, what's that do for the 4x? Okay, how about the -4? Good. And the plus 1? And what's that give you? Good. Okay, and then Jeremy, want to try something bigger than 4? Okay. Got the simple one. And increasing. Okay, so this one says to find the local maximums and minimum values. Now it says values because this one here, I want to show you something. This is what you should look for. I went decreasing to increasing, so there's a local max or min there. I went from increasing to decreasing, and then again I went from decreasing to increasing. So we have 2 of what type, max or min? Decreasing to increasing. To minimums, right? This chunk right here, this, and this are minimums. So where do the minimums happen? Min at, what's that? Not always. What's that? If it doesn't, then there's no max or min there. That's the way that notes where it can go increasing. That can happen, and it will happen. Okay? So anyways, what's the first min at? -1, right? So we know -1's the x value. We'll figure out the y in a second. Where's the second min at? 4. Good. Okay. Where's the max at? Good. Okay. So to figure out those y coordinates, you just plug them in the beginning. Just to save you a little bit of time here, I have them written down, I believe. -1's at -4. And 4's at -129, I think. your max is at 0, negative 1. Okay, and we're going to sketch this. So everybody have this that needs it? On the next page and kind of sketch it. Okay, so to sketch this, I'm just going to put down my max and min points and then just kind of refer to my table for where I'm increasing and decreasing just for review. So again, my first min was negative 1, negative 4, right? My first max was 0, negative 1. And then I had, I'm not going to be able to do this one, but we had 4, like negative 129. It's way down there. Just put it like right here just for sake of doing it. Okay, so how does our graph start before negative 1? What's it doing? It was decreasing, right? So that means it's coming up from the top or down from the bottom? Down from the bottom. I kind of said that kind of weird, didn't I? It's down from the top, yeah. Okay, so it's coming down from the top. There we go, like that.
Do you have to know where that crosses through?
You could figure that out because it's an x-intercept, but for this section, no. We'll do x-intercepts in another lesson. Okay? All right, so now, and we know this right here is a min, so it's going to cup up and come back to here. What happens to the next point? That's a what? It's a max, so it's going to go back down. And then it's going to come all the way down to negative 129, even though this is not to scale. It's going to hit that, and then it's going to come back up looking something like that, roughly, the W look for a fourth degree. Okay? Any questions on that? Yeah, that would be the absolute. And that would be the absolute. Now I want you to start understanding, we did talk about absolute and local, right? I think you were here for that one. So on this graph here, this graph goes forever up to the left and forever up to the right, correct? But we know there's nothing below these two down here. So which one's the absolute min? The negative 129. That's your absolute. There's nothing lower than that. Now you can't have an absolute max in this one because why? Because it keeps going up forever. So your local max would just be this guy, and that's all you can call him. Okay, that's the difference between the absolute and the local min and max. I know we were a little bit gray on that last time because of on me. So, all right, so let's try example 3 here. So find the critical numbers, intervals of increase, decrease, and local max and min values of the function. A little more difficult derivative, so I want you to try this. Okay, go ahead and try this one. I'll pause the video. So let's see how you did on your derivative part here. So your derivative should have been, you should have got 2 minus, and then 2 over x to the 1/3. Just pushing the x to the 1. You might have x to the negative 1/3, but remember, drop the 2/3. That makes the 2/3 times 3 is 2. That's where the 2 comes from. 2/3 minus the 1 from doing the power rule makes it negative 1/3. Okay, everybody okay with that one? Just the derivative there. Okay, so now you could write it as a couple different ways. You can get this to be together, which sometimes is helpful in finding critical numbers, because right now, the way it's set up, we have to figure out 2 minus, how do I make this a 2? Okay, well, it might be easier to get a common denominator and then actually see what over what is going on. So to do that, you're going to go ahead and times x over 1/3 to top and bottom of this, like so. And now you can put them together. So you'll have 2x to the 1/3 minus 2 over x to the 1/3. Then you can take a 2 out. And you're this. It's a little bit easier f prime to see. Okay, so what are our critical points? Is there anything that makes the top 0, which it makes the equation 0? 1, yeah, 1, because 1 cube rooted is just 1. Okay, so 1 minus 1, that's the first one. That's the only one for the top. And 0. 0 is a problem because the bottom. So we got 1 from the top. I'll put top here for your notes. 0 from the bottom as a D and E. By D and E, I mean does not exist because we can't divide by 0, but it makes it a critical point still. Okay, so we're doing our chart now. Okay, we're still doing our same stuff. We have 0 and 1, so we're doing x less than 0, x bigger than 0, less than 1, x bigger than 1. Okay, now this is the tricky part, maybe for some of you. What is our factors going to be? So it's not factors sitting next to each other. What is our factors going to be? Sorry, say that one more time. You can do it that way, or we just have to think instead of multiplying, we have to think about dividing, because really it's factor over factor, right? So these are still our factors, and that's where we got our critical points. So you're still going to write it like this, and this. Just two factors. Because when you divide, you still use your plus or minus rules. Plus over plus is a plus over minus is a minus over minus is a plus, etc. Okay, so you do plus minus, increase, decrease. Okay, so if I do something less than 0, okay, let's do negative 1. What's the cube root of negative 1? Negative 1, right? So negative minus 1 is negative 2. Cube root of negative 1 again. What's a negative divided by a negative? Positive. So it's the same rules. It's just we're just doing division of factors now. Okay? So that gives us increasing here. Very good. Am I losing anybody yet? Besides the boredom? Okay. Between 0 and 1. 1/2. Okay. Or maybe we can go 1/8 or something to be easy with the cube root. Cube root of 1/8 would be 1/2. So it would be a negative. 1/2 minus 1. Cube root of 1/8. Does everybody understand why I picked 1/8, right? Because 8's a perfect cube. Just makes it easier to do than like a 1/2. Okay. That would be a positive. I get negative and a positive. It gets me decreasing. And something bigger than 1, we can do, whatever, 8. 2 minus 1 is 1. And that's going to be positive. So, does this one have a max or a min? Or does it have one of each? One of each. Increasing to decreasing, decreasing to increasing. So from increasing to decreasing, the first part is a what? The 0 is a, good, 0 is a max. Looks like max is at what? 0, 0, huh? Okay. So I put a 0 and 0. I got a min at 1. When you plug 1 in, you're going to get negative 1. Okay, and that's it. Okay, gave an extra page in this we didn't need, so that's good. Skip a slide. Okay, so first derivative tests for absolute extreme values. Let C be the critical number. So what this is saying essentially is that f prime is positive for all x less than c, then f prime is a negative for all x greater than c, then the absolute max value is what you get. So essentially, I know I just read that to you, but essentially if you get the increasing to decreasing and there's nothing above it, okay, like I talked about on that negative 129, that makes it your absolute. Okay, so you have to look at your graph. That's what it means by x greater than c. More, but let's get to example 4 here before people have to go. So find the absolute min value of the function. So it's telling you it's an absolute min. It also says x greater than 0. So that means if 0 is a part of what, like if we get 0 as a critical number, we're not going to count it because we're not including 0. Because it wants, essentially, it's cutting off our graph, correct? So whatever this graph looks like, it's only looking past the y-axis. Okay, it's only looking to the right of the y-axis for x greater than 0. Okay, so I'm still going to do my derivative. F prime, derivative of x is 1. 1 over x is the same thing as what? X to negative 1, so it would be minus 1 over x squared, right? Derivative 1 over x would be 1 over x squared minus. Again, it helps to do your critical points to have these into one fraction. So I'm going to turn this into x squared over x squared. Okay. Is everybody okay with that? All it is a common denominator there. So now we can see, if we set this equal to 0, it's going to be x plus 1, x minus 1, all over x squared. So here's the problem. How many critical points do we have? Let's say there's no restrictions. How many? Yeah, we have 1, 2, 3. We have 3 critical points. We have 1, negative 1, and 0. But by my restrictions, that's not counted and that's not counted, because we're not looking at that part of the graph. Does that make sense? So how many regions are we really testing? One number, but that makes 2 regions, correct? So I'm looking at x less than 1 and x greater than 1. Okay, so x plus 1, x minus 1, and then the x squared is what's being divided. So we get plus or minus, and then increase, decrease. Okay, so if we're less than 1, we'll just do, we can't do 0 though, so we have to do like 1/2. I get a positive and a negative, which makes a negative on top, over a positive. Because it's like these two are together. Why is it a thing? Because they're both on top together. So like when I'm trying to figure out, I'm trying to figure out when they're positive and negative, I have to put these together. So I get negative over a positive gives me a negative. Okay, and then let's do greater than 1. So a 2. Positive, positive, positive. So I have increasing to decreasing. Okay, increasing to decreasing. Oh, sorry, I did it backwards. That's good, because I was just going to say, wait a second, I have a maximum. All right, so decreasing, right? Yeah, to increasing. There we go. So we have decreasing to increasing at 1, which makes it our minimum value. Now things make sense. Okay, so that means then that would be at 1. And what is that point then? 1 plus 1 over 1 is 2. So 1, 2 is your minimum. Okay, all right, that's it.